that at most 2 transformers will be struck by lightning in a week. Now, this first of all is testing on the Poisson distribution, which we know that for Poisson, we say the probability of x is taking the mean power x, then Euler's constant or natural logarithm minus the mean, you divide by x factorial. Of course, the lambda is the mean. This lambda is the mean, and it's the one given 0.4. So this one, so this is the 0.4 per week. Very important. 0.4 transformers per week. Otherwise, if the question is asking you in 2 weeks, in 4 weeks, then you must adjust this one. But if it is still per week in the requirement, then you can use the way it is, 0.4. But if it is in 2 weeks, then you adjust this one to be 0.8 per 2 weeks. If it is like, say, in 3 weeks, then you multiply by 3, so it becomes like a 1.2 per 3 weeks. I hope that's clear about it. Then we have been asked now to use or to determine the probability of no transformer. So you can say here that Roman 1, probability that x equals to 0 shall be, this is 0.4 power 0, then Euler's constant minus 0.4, then all this divided by 0 factorial. 0 factorial. Now, how to use the Euler's constant? Of course, we just use the calculator. We have going to use the shift. So first of all, we know 0.4 power 0 is always 1 by definition. So 0.4 power 0, that is always 1. Then my calculator is still on regression mode. I can change it. I take it back to the normal computing. It's okay. Now we come to E. We use the shift. Then we look for that x, E with the power x, which is actually on the far end, just below the on button, the third button. It has an E. Then now we minus 0.4. Do not power it. Already it is powered. If you use if you use a shift, it's already powered. But if you use alpha, then that is not powered. That's when you press now the power sign. If you use alpha, but I've used shift, so I don't need to power it. I just press shift, I press E, then I press minus 0.4. This is 0.67. So should you divide this by definition, 0 factorial is 1. So this is 1 times and then divide by 1. So the answer remains to be 0.67. So the probability that no transformer is struck within a week is so high, is 0.67. So there's a higher percentage that you don't need to worry. The company does not need to worry so much. So Roman 2 is that you have been asked the probability that at most 2 transformers. So at most 2 means, so probability that at most 2 means x is less or equal to 2. At most, that 2 is the highest. So we can say it is actually probability of x equals to 0 or, so we can say x equals to 0 or 1 or 2. So probability of at least 2, at most 2 means 0 or 1 or 2. So what we are going to do, we have already done the 0. We do the same thing for 1 and for 2 in this manner. We can have, so probability that x equals to 1 equals to 0.4 power 1, then E minus 0.4 divided by 1 factorial, and then probability of x equals to 2, this is actually 0.4 power 2, then E minus 0.4, then divide this by 2 factorial. So we look at the solution here. So when it comes to 0.4 power 1 is still 0.4. So in our case, we'll be having 0.4 multiply by shift E, then minus 0.4. We divide by 1, which is the same answer. So this is 0.268. 0.268. The other one is 0.4 power 2 then multiply shift E minus 0.4 is 0.107. We divide by 2. Divide by 2 because 2 factorial is just 2. So this is 0.054. That tells you that the probability is diminishing, that there is no much possibility of many transformers struck within. So we can say that our answer is that therefore, so probability that x is less or equal to 2 shall be, for 0 is 0.67 plus 0.268 plus 0.054. Our final solution shall be, if I add this, 0.67 plus 0.268 plus 0.054. This is coming to 0.992. There is a very, very high chance that not more than 2 shall be struck, only a maximum of 2. So almost 100%. So you don't need to, there's no cause of worrying that we can have so many transformers being struck. And that's all about that part A. Then part B.